So this particular talk will be interesting from the perspective that you have learned a bit of remote sensing by now. You have seen a few tutorials where remote sensing is being used for different applications, including things like floods, including things like change detection, emission inventory. And you have also looked at a few computer vision applications, such as, let's say, object detection for healthcare. You have seen all those applications. So in this particular talk, we wanted to see if we can detect kilns, brick kilns from space, which is from satellite imagery, and use them for regulation, enforcing compliance, etc. How many of you know what a brick kiln is? How many of you have gone in a train journey through rural India and you have seen those chimney-like structures? So sometimes when you see those chimney-like structures, they could be sugarcane plants, and sometimes these are things like brick kilns. So we will start by discussing our main problem again, which is air pollution. We have discussed that it's a major problem in India. It kills 7 million people on an average every year, and a significant number of those fatalities occur in India. So you would have seen that in the entire world, Southeast Asia has a very high incidence of air pollution and related effects. So this is what a brick kiln might look like. Now, does it ring any bell? When you go through on a train journey, you might have seen these stacks, these chimney-like structures emitting some amount of smoke. These are not the same as your thermal power plant. I don't know if you've seen, do you see the thermal power plant right across the campus? So if not, you can always just fire up Google Earth and get a sense of why these things look different and how they look differently from the space. While it's firing up. So brick kilns can contribute roughly 8 to 14% of air pollution in India across specific belts. Okay, Google Earth is indeed starting up. Now if I open okay, so this is the thermal power plant which we see from the campus, and this is the Sabarmati river. So we are here. This is where our campus is, and this is where we can see the thermal power plant. So you can see that this is significantly bigger in size compared to the stacks which we were seeing, and it's a different kind of a composition. And the smoke you're seeing currently in this case is white smoke. Typically, whiter the color, the lesser harmful it is. Typically, not always. Whereas if you were to see a brick kiln, so we may need to go to, let's say, Adalaj. Okay. This is a brick kiln. How it looks from the top. You can see the chimney. You can see the reflection of it. You also see it in different forms. So this seems to be circular-like structure. This seems to be an oval-like structure. This is where the stacks of bricks are typically kept. So you can see that these places are very close by in vicinity. Why do you think people may end up creating a lot of these brick structures where they're creating these bricks very close to each other? Why might it be better to create these brick kilns or these sites where they're creating bricks very close to each other? One is transportation. Yes, other? So imagine if, so the labor which is going to work, you will often end up contracting them. So they can work across multiple of such kilns. So again, there is generally a market which is being built up, similar to the, like you'll see a lot of companies together. You'll see a lot of food outlets together. So there has to be a sort of a market-like place. In this case, it's the market for the brick kiln workers. You can see that all of them will typically be very close to each other, and they may often be owned by the same person. But this is what we'll end up seeing, that this also creates a problem. If many of these are very close to each other and they're emitting pollution, that will create a very locally high polluted area, because you have multiple of these pollutants very close to each other. And so do you expect the brick sector to grow or to slow down in India or across the world? Grow, because rapid urbanization, more buildings are being constructed. You can see that a lot of people are now moving into their individual homes as opposed to larger families staying together. So each of them demands bricks. And it is said that the demand is only increasing by a significant amount as per some studies by some statistics. So we know that they cause pollution. We know that the urbanization is only going to require the increase in the production. And we also know that, very importantly, these employ a large number of population, large number of people whose livelihoods depend on them. So therefore, I want to ask this as a question to you. They cause pollution. Should we close them down? Why or why not? One is employment. Second, there is a demand. We need to satisfy the demand of getting more bricks, getting the construction. Without that, of course, you can come up with better materials, etc. So that seems not like a very good solution. But what do you think would be a good solution? If you can, sorry, can you be a little louder? Okay, so let's say there are some illegal kilns, you want to remove them. Again, you'll have to have a very whole perspective on it, as opposed to, again, sitting in AC rooms. For us, it's perhaps very easy to say that, including me. So therefore, when we publish this specific paper, I wanted to show you this. This is published in this journal called JCSS, ACM, Journal on Computational, what is? So we wanted to very clearly mention that the scope of applicability is for academic research purposes. We don't want that this particular report that we have published is taken up in some higher court, and because of that, million people lose their livelihoods. We don't want that. We want the whole approach to be more participatory, that it is, let's say, perhaps going in the future that such things are taken into very seriously, but we don't want people to be losing their livelihoods and just because some researchers somewhere have published some paper. We don't want that. And we also want that the actions are not punitive and they're also taken into consideration across all the different stakeholders. So we have realized that we can't slow down the demand. Naturally, we perhaps should slow down the demand. So then we have to figure out that, can we look at different technologies? So instead of your wood, which was being used as a fuel, what do we currently use as a fuel for cooking? LPG, and what is the other equivalent? Now, a lot of people don't use LPG also. We use something else. Electric is not too common yet in India. What is the next thing after LPG, which people use? We don't use CNG. Something similar, but not CNG. What do we use? What is the gas that you get with a pipe connection? PNG. Like not CNG, but PNG. So we use that pipe natural gas in households. That's with a meter. How many of you have PNG at homes? The others are on LPG, I believe that. LPG cylinders. Okay. So you can see that there is a transition of better fuels. Similarly, if we were to use better fuels here for firing, we could get improvement in the reduction in emission. Secondly, there is also better technology overall which we could use. So we can see that the leftmost one is the circular fixed chimney Bull's French kiln, which is the one I showed you, this one, something like this. And then you have a slightly better, more efficient thing, an efficient version known as fixed chimney bull trench kiln. So it's circular, this is fixed, the shape is more oval in nature, and there is a very specific path in which the fire has to follow in order to have the baking done. So this one we saw, like this specific one is this oval-like structure. And in Gujarat, I don't think we see a lot of the next variation, which is known as zigzag. You can see now here the path of the fire flow is zigzag in nature, and this is supposed to be much more efficient. And you can see that the overall structure as seen from higher altitude is more rectangular now as opposed to being oval. And there are studies that this structure is about 40% more efficient. So then the next question, should we shift all the previous technology to zigzag? Yes? No? If this is more efficient, you don't want to compromise on the production of kilns. Does this look like a good solution? Or will there be some trade-off? Okay, so there will be some production outages when you do the conversion. Secondly, is the conversion free? Who pays for this conversion? Do the owners pay for the conversion, or do the governments pay for the conversion, or is it a, let's say, 50-50 split? So therefore, there are such conversations always around. Therefore, that's another view I want you to take out of the summer school. It's not just that we solve the technology problem and we are done. There has to be a policy solution. There has to be a funding solution. There have to be multiple views that we have to take of the problem. So perhaps there will be some subsidies given to convert, etc. So it needs to be thought of. So zigzag is indeed more efficient. And since we discussed air pollution, we also mentioned that perhaps Delhi is very polluted, etc. So let me show you this. Let me see if I can find that. I'm trying to find out an NCAP ruling which had mentioned okay. So they mention in terms of the measures, enforce the use of zigzag brick kiln technology in brick kilns, specifically for the Delhi NCR region. This was very strictly recommended that you convert the brick kilns to the better technology. Do you think this has happened? No? Anyone thinks that the brick kilns in and around NCR have been converted? No one is hopeful. Delhi seems to be still polluted. Somewhat? Okay. We'll see through this talk. So in order to answer such questions, what do we need? That have the brick kilns been converted to a better efficient technology or not? How many of them are violating some government related rules? You need to identify them. You need to identify the technology. So therefore, which brings us to the problems or the objectives that we're trying to solve. The first is we want to geolocate kilns, which is tell exactly in terms of lat long where a brick kiln is. This helps us in survey management, and it will help policymakers understand where we have brick kilns. It's a very informal sector, by the way. It's not something like the thermal power plant where you have to go register, like ideally it should be, but it still seems to be very informal sector. And in terms of the air quality researchers, they need to know where the pollution sources are. Like yesterday, Alok showed you, we need to exactly know where the thermal power plants are. Similarly, we need to exactly know where the brick kilns are, and then we have some factors for each of them. And then when we can use these factors as well as metrology, I can use the simple rules of physics and some models and tell exactly the amount of pollution which will be there at any particular place. From a first principles perspective. The first principles perspective is, let's say if this is a polluting source, I know the wind direction and I know the way the chemicals react. I know how, let's say this is emitting CO, CO2, NO2, SO2, and there is a certain amount of CO2 in the air. So I can see then how these particles will combine. And if the wind is blowing this way, I can tell exactly the amount of pollution which will be there at the place where you're sitting. And we want the researchers to be able to create this. This is known as an emission inventory. And we saw one emission inventory yesterday, which Alok showed. We also want for compliance monitoring. We want the policymakers to have access to which of them are non-compliant as per the rules. And as well as we also want to analyze the trend of their evolution over time. Are people using better brick kilns? Is their efficiency improving over time or not? So these are the kind of questions which we want to answer. So the first thing you might think is, I showed you in about 5 minutes that I could have found a lot of brick kilns. So could we use this methodology, like open up it in Google Earth and find out brick kilns? Can I do that? It won't scale. How many minutes, hours, days, weeks do you think this will take if I have to span the entire India? Just a lot of time. So without getting into any estimates, you will see that you'll have to basically move through the entire thing. And then you'll also get these things which look like something, but they are not, look like. So it's a problem of, we have found out more here just by scanning some area. But this was an area I knew where we had brick kilns. So it was a solved problem and I was just using this for illustration. But if we had to do this on a pan-India level, so let's pick up some other random area. What do you think will be the probability of finding a brick kiln there? Let's say we pick up something here. Close to 0. This looks like a mountainous, forest-like area. If we were to go to some other place, I don't know, this place. So think of the problem. We have to do this across India. Seems like a very tedious and almost impossible exercise to do. And you can also not update this dynamically. So which means that you cannot really look at the growth over time. If you have to figure out the growth, you'll have to do the exercise again. It seems very painful, excruciating pain. So when we're also doing this detection, we also want to get the area. That is important. The area is a direct indicator of the capacity. So therefore, what we're saying is that you have looked at object detection earlier. Typically, the object detection which most times we end up using is known as axis aligned, which is you'll get these rectangles which are parallel to the axis of the image. But in this case, perhaps what is more important is an oriented bounding box, which is it's tightly oriented and it can align well with the brick kiln dimension. So it's perhaps more useful to figure out the exact area. The area is going to be a very good proxy for the number of bricks you produce. The number of bricks you produce will be a very good proxy for the emissions that you have. Can you use segmentation? Yes, you can use, but segmentation is a more expensive process. So, for example, if you were to just look at the left-hand side, then what you want to produce is like estimate from the model is one of the coordinates and then the width and the height. So 1, 2, 3, 4 parameters you're trying to learn or predict. Whereas in the oriented bounding box, you are looking at x1, y1, x2, y2, x3, y3, x4, y4, and then the theta angle. Right? So you'll end up requiring more parameters, but it's always, so you can always go from oriented bounding box to axis aligned, but you can't go from axis aligned to oriented bounding box. So then what we planned to do was to do scalable object detection using satellite imagery. So like Google Earth, we will still be using satellite imagery, but we want to scale that up. So this is how the output would look like. First, it would be detection. Second, we would also do the classification of the type. We've looked at 3 types: circular, oval or fixed chimney, and then zigzag or rectangular kilns. The last one is the most efficient one. So we want to do this classification. Third, we want to look at the compliance scores. So there are scores like the distance from the water body should be at least 500 meters of distance. Why? Why do you think? Why should they be at least 500 meters away from water bodies? Okay, one is they pollute water. Maybe they don't. Let's just keep that aside. But why do you think, aside from that? What is a brick made of? Soil. Yes. So clay, soil, etc. Where does that come from? Yeah, so the raw material often also comes closer to the water bodies because the soil is of certain nature that you need. If you pick up all the topsoil from there, what happens? If you were to pick up a lot of topsoil around the water body, what will happen? Do you increase the chances of flooding? So therefore, can you see that these two problems are interrelated? In fact, there have been reports in the past where the shapes of certain rivers and water bodies have changed because of kilns being constructed. Because the topsoil has been very heavily, due to human intervention, being modified, so the stream flow itself changes. And whenever the stream flow changes, you are very likely to have things like floods. And then there are others like interbrickle distance, because if many of them are very close to each other, you'll end up creating a cluster which will be a highly polluted region. So the people who are living in the vicinity of these, they will unfortunately have the worst effect. So that's why we also mentioned that we need a whole participatory effort. Again, sitting in big cities, we may say that the farmers are to be blamed for the air pollution in North India. In this case, we may say the brick kiln are to be blamed. But the people who are living there, they have much more exposure than what we have. So therefore, we need a more participatory approach to understand that why, despite these health effects, they still are forced, or they're still working in these adverse health conditions, or the conditions which are not very conducive for their health. Why do they still need to work in such places? So overall, if we look at the end-to-end pipeline, we want to first do a class-aware brick kiln detection, automatic compliance. This is the air pollution simulation which I was mentioning using physical chemical transport models. We need to first, these are the brick kilns, by the way, in and around Delhi NCR. We get these different sources or emission points. From that, we know the rates, approximate rate, which is proportional to the area of CO2, NO2, SO2, etc., which would be produced. And then we know the wind vectors. And then we can very precisely tell the expected amount of pollution at any grid point in any particular city. So now the advantage of some setup like this, simulation setup like this, is now I can because it's a forward model, we can now say that, let's say if some of these red dots I were to convert to better technology, can I then now exactly tell how much reduction in pollution will I have in this part of Delhi? Yes, because I know how much would be the reduction in emission and then how much would be the reduction in concentration. So there is a difference between emission and concentration. Emission is at the source, concentration is at the target. Let's say if I am looking at IIT Gandhinagar, I am looking at the concentration of PM, that is at the target. Whereas if I am discussing about the thermal power plant, I should be more looking at the emission. And then importantly, I can look at the evolution of technology over time. So because I have scalable methods, if I were to repeat this analysis across the satellite imagery, across time, I can figure out that what is the evolution or the number of kilns across time. So this is what we want to do. So we ended up creating this data set of about 30,000 kilns across India, which was a very large manual annotation effort across these 3 different categories. 1500 circular, 13,000 fixed or oval, and 16,000 zigzag. We ended up using different resolutions of satellite imagery for this. So we use Esri or very high resolution imagery to do the annotation, to do whether this is a particular image or not. Like this is how a kiln would look like, similar to the image quality which I showed you in Google Earth. For annotation, we would use that. You can see that the annotation means you draw a bounding box, an oriented bounding box across the kiln, and you tell the category. But for prediction, when we want to scale it up, we cannot use Esri or Google Earth like images. Any guesses why? Why can't I use Google Earth or Esri like images? One, it will take more time, that's one. But I was willing to spend more time. You're not allowed, so you'll have to very carefully read through the terms of services. They do not allow models to be trained or derived products to be used on their satellite imagery. So of course, you can, perhaps there are certain buyer clauses, etc. But if you directly use those products, you're not allowed to do that. But you can still do the annotation on them, because the annotation on them, if you do, the annotation is basically, think of this as a latitude, longitude mapping that I've done. That I can then transfer to a freely available imagery, which in this case, I'm using Planet imagery, which is a freely available imagery for us, for researchers for use. You can see that the image quality is significantly poorer. So the above one is about 0.3 meters per pixel. This one is about 5 meters per pixel. So you can see that there is a significant reduction in the image quality. Perhaps as a human, you cannot decipher whether this is a FCBQ or a zigzag. But that's not the point. Machines still can see what humans can't. So what we plan to do is we get the annotations using high resolution imagery and then overlay them on lower resolution imagery, and then you can train your models on lower resolution imagery, where you're allowed to do that. So in order to construct the initial training data, we looked at 4 regions. First, we wanted to look at regions which are very polluted. So we looked at Delhi region. We manually scanned each and every meter in this region, and figured out where the kilns are. And naturally, as you'd expect, none of them are in the main city itself, but all of them are in the vicinity of the city. We also looked at Lucknow, which is also a very highly populated region. So I'm telling you the criteria which we use. 1, highly polluted. 2nd, highly populated. In this case, it was Lucknow. 3rd, we looked at West Bengal airshed. We took a smaller region. And interestingly, can you see that all of them are located very close to the water body, which is expected. And 4th, we looked at Ahmedabad, where we saw that, so we wanted to also have some geographic diversity. The soil in Ahmedabad is very different compared to the soil in West Bengal. You look at the color, texture, etc. And similarly, maybe Delhi, Lucknow are different. And because Ahmedabad is also a non-attainment city, which means it's not adhering, it's not within certain limits of pollution, which we expect. So, but you'd expect that overall the number of kilns is much lesser in Gujarat, because not that kind of a sector is not, industry is not very prevalent here. This was the region from where I was showing you on Google Earth, and this is closer to our campus. So we overall wanted to create a data set across these 5 states in the Indo-Gangetic plain, primarily because this is where you have a lot of pollution. This is where a lot of brick construction happens. We created our own tool for annotation purposes, which was, I think, either a Jupyter Notebook widget or some Streamlit app, something of that sort, which would help us firstly figure out the grid and then also help us overlay these bounding boxes and specify their class. So this is the amount of effort that we had to put across creating these data sets. So overall, when we created this initial data set, it spanned an area of about 15,000 square kilometers, which we fully annotated, and had about 1,600 kilns, and the annotation effort required was about 125 hours across a large team. This project has now taken roughly more than 2 years of work, what I'm presenting today. So, sorry, how did we get the? So this image that we are getting is basically read from a satellite source. We have the whole satellite imagery of a particular city. We have an airshed. You divide that into grid, and in that grid, you're able to read different images, and you can move across those images. Yes, these are annotated by the lab members. Yeah, this didn't require a lot of GIS. So the annotation tool that we built was handling many of those things internally. So they had to view it as image annotation, not so much as a GIS exercise. So when we built the app, we hid away some of that complexity. Can you be a little louder? Yeah, so why make this app when we have tools like RoboFlow, etc.? So one, this was specifically built for our use cases. If you have to use tools like RoboFlow, you would have to first download the entire imagery and then have image 1, image 2, image 3, image 4, etc. You're also losing out that relationship between lat long and the image. You'll have to, or specifically or separately, you'll have to do that mapping. Thirdly, this could be done on the fly because this is read from a source, from a base map, and then you can just do the labels. And next, you can also transfer the labels. So because of those advantages, we initially did start with something like RoboFlow or ImageN or some tool like that. But we figured out that this would be better, more scalable, and we also wanted to do things on the fly. So currently you're seeing just one part of the interface. The next part was where we made predictions and then we had the humans correct those. Again, that made more sense if you can define a big geographic area and then you can have predictions in those, and then the humans will go through each of them at a time, as opposed to looking at just as a image like thing. And sometimes you also have to look at, like, you need to pan, zoom, etc., which again you don't get in image in RoboFlow like tools. So why was the data set? Why was the data set biased towards these two? Because that's what we have in the data set. I mean, this is the general distribution of kilns across India. We'll see more when we look at the larger data set. We have primarily 3 types of kilns. We have more efficient kilns, which are more prevalent in the West and some of them in South India. But these, across most of the kilns in India, you will have these 3 categories. There is another category known as just a clamp, which is typically in the local languages, that's called just a bhatta. So it's a very small like structure, but that you can't see from space. For that, you need drone imagery or something better. Yes. So these would, I would say, account for about 80 odd percentage of kilns. So then we used YOLO. So now, after having done the annotation, it becomes closer to the computer science, computer vision problem that we've seen earlier. We use YOLO like object detection models, and we use 2 variants. And we were looking at it from the oriented bounding box variant, and then we evaluated the map scores. So if you notice that if we use YOLO 11 OBB, the map scores turned out to be better than the others. We looked at the weighted map across the different categories also. And importantly, we also failed when we looked at training and testing as 2 different regions. If you trained your model, let's say on Delhi and tested on Lucknow or tested on West Bengal, the accuracies were very poor. Why? The nature of the soil, the characteristics of the kilns itself. So the brick kilns in Punjab, Haryana are typically bigger in size as compared to, let's say, in Bengal. That's another. Maybe the distribution itself changes. You have more kilns of one type in one region and of another type in some other region. So there are these different things which we found out that the performance is bad. So then we wanted to expand the data set. Like we didn't want to limit ourselves to these regions only. So we started off with the initial data set. We looked at the entire test region where we wanted to make the predictions. And we made the predictions using the trained model. We found out 26,978 kilns, predicted kilns. Are all of them going to be correct? No. So we started off with the predicted data set, and then we had the humans verify whether the labels are correct, whether the location is correct or no. So then we had hand annotation, and we found out that about 15,000 of them were correct. So purely from a accuracy perspective, you might see that this is not very good. 15,000 correct from about 27,000. But from a utility perspective, now we have been able to add 15,000 kilns. That is what is more important. So we repeated this exercise multiple times, which I'll come to, not just once, multiple times. Not directly active learning, but we would say that we make a prediction and then you would see that if the prediction is correct or not. Not directly active learning, we are working on those variants currently. So when you pose this as an active learning problem, you will have to be, firstly, active learning for classification is a simple problem. Active learning for detection, you'll have to think more deeply. Because for classification, for each image, you have a class, whether it's a cat or a dog or something. Whereas in this case, we have, I would say 99% of India does not have a brick kiln. So it's all background compared to the 3 classes of interest. So what do you do with those images? You need to also sample those to get a diversity of that this is a negative image for a kiln. So you'll have to think of those things also. You'll have to think of better acquisition functions which work across object detection tasks. Therefore, if you see the literature for object detection and active learning, it's much lesser compared to active learning for classification or for regression. So if we looked at the final number of kilns detected per state, you'd see that UP, Bihar, West Bengal, Haryana, Punjab, you can see the numbers. And you can also see that FCBK for UP is significantly more than the others. Whereas for Bihar, can you see that the zigzag is much better, more? So therefore, sometimes it's a case of the initiatives taken. So in this case, I know some leading researchers in this space. They also discussed a lot with the Bihar State Pollution Control Board, and they really took it as an important initiative, and they were able to get these conversions done. So therefore, it's also a lot of how much the local political will is at that place. And if we were to look at the individual kills detected across the 5 states, circular primarily UP, fixed spread across everywhere, but again UP seems to have a lot. Zigzag, you can now see the Delhi around Delhi, it's very high density of zigzag. And in Bihar region also you can see a very high density, and perhaps in some regions of West Bengal also. So post this, we wanted to answer the compliance answers. Which of these brick kilns are compliant as per the rules, which of them are not? In order to do that, we had to look at some other resources, like we looked at OpenStreetMaps. We looked at railway tracks, highways, rivers, schools, habitation. We looked at the hospital records, nursing homes. We also looked at the population data from Landscan. So all of them were required so that we could then tell how many of these kilns are violating certain siting rules. Like there were some distance-based compliance rules. The distance from human habitat should be greater than 800 meters and the distance between 2 kilns should be greater than 1 kilometer. Now we could easily answer such questions because we had access to these OpenStreetMap and related data sets. So we found out that if we look at the kilns which are less than 800 meters from human habitation, you would see that UP has a significant number of these and lesser in Bihar, West Bengal, Punjab, Haryana, but they also have lesser number of kilns overall. Similarly, if you look at 800 meters from hospitals, there are more than 6,000 such non-compliant kilns in UP. Distance between two kilns less than 1 kilometer. So overall, perhaps shockingly, perhaps not so shockingly, we found out that 70% kilns are violating at least one rule. Again, I come back to my question. Should we shut down all of them? It's a hard question. There are both sides. Perhaps some middle ground could be done. Some help could be given. So it's not a very easy answer to suddenly shut down things. Sometimes, in fact, some knee-jerk reactions can also create more problems. Like, I don't know to what extent this happened, but when the odd even happened in Delhi, do you know what the odd even policy was? On odd days, odd number of vehicles will run. On even days, even number of vehicles will run. I heard some small subset of the population, they mentioned that their pollution will in fact increase. Why? What do you think will change? What will they do so that their pollution will increase? Sorry? Buy more vehicles, and because the other vehicle will probably not get used a lot. So what kind of vehicle will they buy? Second-hand, old, inefficient. So it's very hard to figure out exactly what is going to happen and if such punitive actions are taken. But that perhaps was a very small subset of the people. I don't know what exactly happened. There are such studies which looked at the effect of such policies. So this is one of my favorite slides from this entire presentation. Delhi is bad, air pollution is bad. There are always negative news in around Delhi NCR. Look at the evolution of zigzag and the reduction of FCBK in around. Can you see how wonderfully this has taken off? Most of the kilns are now zigzag in around Delhi. So therefore, it's not always a case of that no action is being taken. In this case, a very strong action is indeed being taken. Now, it's a different question that whether the zigzags are operating as intended or not. Have the brick kiln owners been trained sufficiently so that they can make the best use of the technology? That is a different and harder question. Delhi, we can see the improvement. Lucknow, not yet. So therefore, again, it's a case of the enforcement agencies and the penalties and the incentives which are given. Now, if we look at the emissions, they have a significant amount of PM and SO2 emissions in terms of tons per day. This comes from some certain factors, like zigzag, there are certain factors. For FCBK, again, there are some factors. And then you also have the area and the number of kilns, number of bricks produced by each. So this is the simulation which I mentioned earlier. Once we have the weather forecast models and we have the chemical transport models, in this case, a particular variant called CAMEX is used, and you know the emissions, you can pinpoint the contribution of any particular emission source to the total PM. In this case, it seemed to be about 8% as per some calculations in certain time period of the year. Unfortunately, we figured out that there is more than 30 million people who are living within 800 meters of kilns. So the siting rule says there should be very less habitation around kilns, but 30 million is a huge number which are living close to these. So this is the first part of the talk, which was using planet data and about 30,000 kilns. I'll stop for a couple of minutes before I go to the second part of the talk, and I'll take some questions. Hello. So the question is for OBB, How many points do we need? Okay. So for the axis aligned, we are saying that we just need these 4 points, x1, y1, then w and h. Whereas for this one, we have written x1, y1, x2, y2, x3, y3, x4, y4, and the angle theta. So could we have done with lesser? What does everyone think? So his suggestion is perhaps we use only 2 coordinates x1, y1, x3, y3 or x2, y2.
The diagonally opposite coordinates basically.
Okay, so he's saying we use only x1, y1, x3, y3 and the angle theta. So do you think that is sufficient or are we missing something? So these angles we know are 90 degree. Are we sure that these are always 90 degree? Mm-hmm.
Right, exactly.
Okay. Yeah, perhaps you're correct. Maybe we have just over-specified here. I'm not exactly sure what the underlying implementation uses. Does anyone from the students who worked on this want to answer?
Okay. One of the important things that you have to get notice of that these YOLO models do require all the points to run. So if you do not provide any one of the points, like you will have to calculate it for them and provide it to them again. So it's better to do this.
Okay. Other questions?
So, sir, are you going to do this process of detecting kilns again and again because demography will change? And another question, like suppose I have a kiln here.
So first, let me answer this question. So this question is that every time you change the geography, you will see that the performance was dropping. So does it mean that we'll have to train the model across each geography independently? So that's one baseline model. We hope we don't have to do that. We hope that we can leverage either generalization or we can leverage domain adaptation. And we have been doing some work around that also, including models like GANs, etc., which we use to shift the imagery from one state to the other. Like you would have seen cycle GAN-like implementation, which changed from zebra to horse and vice versa, etc. So we did some work around that, and the initial results are promising. We can get up to 10-15% performance boost by leveraging some of those methods. But we're also hoping, and at the other end, so when you heard from Shatakshi and Devansh on the vision language models, one of the hopes was that we can use these foundational models which do not require tuning on a per geography basis, so that they work across multiple geographies. So that's another effort in which the lab is working.
And my second question is that suppose I build my kiln that is completely legal.
Can you be a little louder? Yes.
I build my kiln that is completely legal and that follows all the norms of CPCB. And after some time, near to my kiln, some more illegal kilns are made. So it is not following that rule that there should be 1 kilometer distance between two kilns. Then when your system will work, then will it detect my kiln also as a illegal kiln or
Okay.
something?
So that's an excellent point. So I don't know how exactly the processing happens, but I'm assuming that if you are a legal person, if you have followed all the rules, which means you have got a registration date. And then we can perhaps go by the registration date. So the one which was registered on time, earliest registered, after that, everything else which comes up within 1 kilometer of that should be taken as illegal and not yours. But this also brings about another aspect. So when we talk about penalties, air pollution, etc., like you must have heard that again in North India, the whole of the entire construction industry is suspended during the winter months. Now, let's say that someone is very properly following the rules. So they put those blue barricades or whatever you've seen around the campus also. So they put those, they ensure that there is dust control, etc. So for them, is it a good action? Should their construction suffer? Similarly, let's say that there are certain very good brick kiln owners. So they're following all the rules. They are also converting to better technology. But when the court order comes, their kilns will also be shut down during the winter season. So that brings about another different problem, that should it be selective? Should it be done on what basis should be done? So it's a hard question again on to how to perfectly implement such a thing.
And are you also looking beyond RGB, like hyper?
Okay, that's an excellent question. Are you looking beyond RGB? So you might think that when we're talking about brick kiln, fire, etc., perhaps the first thing which comes to mind is thermal. But perhaps that's what most of you think. One, if we get thermal at very high resolution, perhaps it adds a lot of it. Perhaps it adds value. But the other important thing is that the thermal differences are not going to be very significant, because while these things are hot, these things are the same things where people are actually walking in this region. So while it will be hot, but perhaps not that hot that it is detectable from space. If we look at other things, other pollutants, so like Sentinel-5 has these missions which are looking at NO2, SO2, etc. Again, we found out that the resolution was not significantly high, whereas with RGB, with certain satellite products, we were able to get very high resolution. So even in those, in a low resolution setting, we were not yet able to see anything, but perhaps there is more work to be done with other spectrum. Okay, so I'll go ahead to the next part of the talk. So one, we saw that there are limited generalization capabilities, which I highlighted. Second, the planet data, which I mentioned, is not shareable again. So you can't make that public. I can't share that to you to be using it for your machine learning models. And we also wanted to create open reproducible data sets. So we ended up creating a new data set and benchmark called Sentinel Kiln Dataset and Benchmark, DB. We note that planet imagery cannot be made publicly accessible under the research program and education and research program which we have. And so it will also make it financially hard to scale. So therefore, we said that we want to create a data set which is open source, openly available imagery, and large scale, much larger than the previous one. We also wanted to have more benchmarks. So previously, we didn't care that much about benchmarks. One algorithm which worked well, we just used that. And third, we wanted to create this large oriented bounding box data set, which are not very readily available. So we have a few axis aligned data sets available in the community, but not so much the oriented bounding box data sets. So this time we expanded the coverage. We went beyond India. We went into Afghanistan, Pakistan, more states in India, and then Bangladesh. So overall, the area coverage was 2.8 million square kilometer. So it's a huge area that we have spanned across these different countries now. And this is the count of brick kilns that we finally obtained across these different geographies. For India, we have a lot more construction and so a lot more area also, so a lot more brick kilns, which is still primarily FCBK, lesser zigzag. Pakistan has a lot more FCBK compared to zigzag. Bangladesh, Bengal, you again see the story is there has been a lot of very positive investment towards zigzag technology. So therefore, you can see that they have a lot more zigzag as compared to FCBK. So we created this data set when we looked at 9 states in India, 8 divisions in Bangladesh, 4 provinces in Pakistan, 34 provinces in Afghanistan. And we ended up looking at around 1 lakh images, 75,000 to 1 lakh images. And the total count of brick kilns that we obtained across these 4 geographies is about 63,000. We went from 30,000 in the previous case to about 63,000, which is a significantly larger jump, and also across the geographies. So this is publicly available or should be publicly available soon. It's currently under review. And because we wanted to use publicly available imagery, so we went to an even lower resolution imagery, Sentinel-2. So this is 10 meter per pixel. Now you can see that this is what an image looks like. Again, perhaps to the human eye, this is not very clear whether it's a brick kiln or not, or what category it is. But that's not the point. We don't want humans to do that using sentinel imagery. We want the machine to do that. So we're giving both the OBB and axis aligned bounding boxes. And we have these different state-wise counts. I will not go into too much details about these. This is the distribution by region, and this is on a logarithmic scale. Again, you can see that UP, and this is perhaps Pakistan, and this is perhaps the Punjab, most of this Punjab side of Pakistan, which tends to dominate. So when we look at India, we got about 42,000 kilns, primarily UP, Bihar, West Bengal, and the number of CFCBK is also larger in India. And you can see that some of the CFCBKs are very close to our current conference venue. Whereas FCBK is more or less spread across India. Zigzag, you can see, is again spread, but you can see a lot of density in Bengal, Bihar, and then close to Delhi NCR. If we looked at Bangladesh, it's primarily zigzag. There have been a very strong regulatory and I would say financial aids towards this. And Pakistan is primarily FCBK. Afghanistan doesn't have a lot because perhaps the terrain is mountainous. So maybe there is not so much scope. So we were able to find out about 600 kilns. But this could also be, we are not able to detect many kilns yet. So models could also be imperfect. So previously we had used the Mosaics API from Planet, and we had looked at big tile imagery. Importantly, when you create these images, unlike your regular RGB, your natural imagery, you also have to create overlap between images. Why? There could be some detection right at the border. So therefore, what should the overlap at least be? No, how would you figure out that it's 20%? Yeah, it should be corresponding to the area and the length of the largest kiln. That is the amount of overlap that you want. So we ended up looking at the time frame from November 23 to February 24, which is the brick kiln season. And we used sentinel imagery. We looked at this surface reflectance. And we split these tiles across these different patches with about 30 pixel overlap in lat and long. You can see these images with the overlap being shown. So now what we did was we started with the previous 30,000 kiln dataset, which was OBB dataset from the previous publication. We predicted across this entire 2.8 million square kilometer. So even the prediction is going to take significant amount of time. On Planet imagery, we were then able to use the hand validation with the Esri imagery or the Google Earth like high resolution imagery. Once we had that validation done, we repeated this multiple times. So you validate, you started from 30K, you validated, you were able to add, let's say 10K more images. You added that to training data set, train again, fine tune again predict on the entire region, look at the new identified kilns. We did this multiple times and expanded the data set to about 63,000 kilns. And then we did the label transfer. This is the important bit. We need to ensure that the exact point which is there in Esri is mapped out here. So there are various subtleties and GIS know-how which is required here, which I'll skip now, including the projection and other things. Sometimes these different imagery, they use different projections. And this is the Sentinel kiln dataset part, not the benchmark part. The benchmark part I'll discuss now. So expansion is you predict on the entire region, then you add hand validation. You predict. Now let's say once you've made the predictions, you got about 40,000 kilns. You will give them to human annotators. They'll figure out that 20,000 of them are correct. You add those 20,000 to your training data. Yeah. So it's in some sense a version of active learning. So the label transfer happens through the projection. So that would be some GIS concept. So in easiest terms, think of this as an Esri. If we have lat long, we have the 4 points. we will have the exact same latitude longitude here. So we need to figure out what does the latitude longitude correspond to the pixel coordinates in the sentinel image. That is the mapping which is needed. Different shape for. So typically the shapes of the brick kilns would be these ones only. Thus far we have not encountered anything, but perhaps if you want to do at that point I don't know whether you should be looking at polygons as the object detection shapes or perhaps just go to segmentation, which gives you more flexibility. But thus far I think whatever we've used is sufficient. So we will be making this dataset public in Creative Commons Attribution Non-Commercial 4.0 license, which means you can use it. And we have also named the files in a certain format. We have provided the dataset in both DOTA and YOLO-BB format. These are common formats used in spatial imagery, satellite imagery as well as for object detection. And then we come on to the benchmark. We look at few benchmark tasks. The first is in the in-region detection. So if we have models trained on the same region and we are testing on the same region, then what is the performance? The second is out of region, which is to say that if you're trained on Lucknow and you were to test on Delhi, then what is the performance? Third, super resolution. So can we enhance the quality of image? This was also discussed, super resolution also discussed yesterday in some extent in Alok's talk. You start with the low resolution imagery, you increase the resolution of the imagery and then you train the models. Does that help you or not? So we wanted to evaluate that. So for the in-region detection, we did the standard 60-20-20 split. We used various models, not just the previous ones, not just simple YOLO models. We also used various transformer-based models and other state-of-the-art models in oriented bounding boxes. And we found out that the object detection was struggling in the classification. It was able to tell it's a brick kiln, but in the class it was having a hard time, which you can understand. It was a very low resolution imagery. So I will not get into the detectors. There are one-stage detectors and two-stage detectors, but I'm just leaving them as a reference in these slides. So we found out that in this case, if you're looking at the two-stage detectors, there is a ROI transformer, there is a H2R box, and there is a PSC algorithm. The best performing two-stage detector was the ROI transformer, whereas the one-stage detectors you can see are generally performing well in this case. The best ones which worked, the best ones for us was the YOLO models with certain variants, YOLO V11 and YOLO 8 world model. And then there are transformer-based models, so detector models from, this was initially, I think Facebook Meta introduced these models. So in fact, RTDTR turned out to be overall best, I think. So then we looked at the out-of-region detection where we had the 60-20-20 split again. Training was done on the UP. And then we tested in the out-of-region. So when we trained on UP, we tested on UP, which was the in-region. When we tested on Dhaka or Pakistan, Punjab, that is the out-of-region data splits. And we were looking at the performances. And you can see that the MAP 50 was high in the in-region performance, which is as expected. Whereas if you look at the MAP 50 on the test region, which is different from the trained region, you can see that the performance dips quite significantly, which is again showing that there is a problem of domain adaptation, or because of the different geographies, we're not able to very nicely predict based on models trained in one geography on the other. So we can see the drop in so whenever we looking at the drop, we should be looking at UP and compared to the others. So that's just the drop in prediction scores that we are seeing. The third task which we saw was super resolution, and we applied them to Sentinel-2 imagery on Delhi NCR dataset with a 60-20-20 stratified split. And once we enhanced the images, then we were using them for training. So increase the resolution, train, and then increase the resolution and test, so that the training and testing both happen on high resolution imagery. So in this case, we were looking at the PSNR as well as the SSIM. There are two standard metrics used for super resolution across 3 or 4 different methods: diffusion, SwinIR, ESR-GAN, and HIT. And then when we looked at the super resolution results, so you can see that compared to the original resolution, the results are better, which is perhaps surprising that we are able to get quite a bit of a performance gain by just leveraging state-of-the-art super resolution methods. So importantly, when we are doing these super resolution methods, we are just doing the forward pass. We are not doing any training. We are not giving it pairs of low resolution and high resolution images. So these super resolution methods may or may not have even seen what a BRICKIN is. They may or may not have seen the indent data also. We don't know that, because we are just doing the forward pass across these different methods. So we scale from 128 cross 128 to 512 cross 512, and we see the performance improvement. And you can see the super resolution plots also. This is the original Sentinel imagery. This is the high resolution imagery from Esri. This is 10 meter per pixel. This would be perhaps 1 meter per pixel. This would be 5 meter per pixel. These are the different interpolation strategies. So can you see that in SwinIR, the image is much, much clearer compared to the original Sentinel? And the others, it's slightly enhanced and slightly clearer. This one seems to be sharpened out a lot. And here perhaps you can see. So we also have to see whether the benefits are coming more due to sharpening or more due to the increase in resolution. We can see the improvement in the class agnostic map by about 15 to 18 units, which is quite significant. So once we have created this benchmark and we have looked at the data set, we want to make this available to the community for a standard benchmark and data set for object-oriented oriented object detection. And there are a couple of other benchmarks like DOTA and HRSC 2016. So this becomes now, to the best of our knowledge, the first large such public dataset for OBB models, which is available for low resolution image. So I believe DOTA and HRSC have slightly higher resolution imagery. So therefore, different applications can be enabled by them. Overall, this is the largest BRICKIN dataset to the best of our knowledge, which is about 80-odd thousand images. And we have looked at more than 1 lakh instances that we have, with a resolution about 10 meter. And there are these different comparable data sets. If you look at the instances and the quantity, so in certain cases, we are significantly better, and we're working at a lower resolution. Now, since some of you had mentioned active learning, and we are also having a tutorial on self-supervised learning in the evening. So these are few of the directions which I think we want to take, and we'd be happy if some of you are interested. So we want to look at the robustness across different geographies. We want to also implement certain self-supervised techniques which work across geographies. We want to leverage things like active learning to reduce the annotation cost. And we also want to maintain the accuracy in different regions. So overall, to conclude the 2 lines of work, we looked at BRICKINs being very important for the construction industry. We also saw that the brick production is increasing over the years, but they're also polluting the air. They are also creating other health impacts, etc. They're also employing some, in certain cases, very young people below the age of 18. So if we were to manually do this labeling, it will be very labor intensive, and we cannot also maintain such an inventory. We can use satellite based imagery, but that also has its own limitations. So therefore, we started off with the satellite imagery from Planet Labs, which is 4.77 meter per pixel. Got about 30,000 brick-kilns across different categories from 5 states. And then we expanded to a publicly available dataset and benchmark, which is Sentinel Kiln DB, which is about 60,000 such images across different countries, Afghanistan, Pakistan, India, and Bangladesh, and across different categories of kilns, and at a much lower resolution. And it's perhaps one of the largest such data set for such low resolution data. So with that, I would like to end this talk, take a few questions.
Right. So the dataset isn't publicly available yet, right?
So we will have to figure out so it's currently under submission. So we have to figure out whether it will be, so it's public to the reviewers. Once we share the URL, it becomes public to everyone. But we can discuss it offline on ways and means to do that. So because this is my last talk, I also wanted to now quickly go through the lab website, discuss about the openings, etc. So if you were to head to the lab, which is sustainabilitylab.github.io, on the homepage, you'll see some of these projects. We'll add more in the coming days. These are some of the featured projects. You can see that we're working on things like healthcare, and we're also working on things like air pollution. And from the domain perspective, from the technology perspective, you would have seen that we are generally a very applied lab. So we want to solve the problems, talk to the stakeholders, take them to the stage where there is an actual change, there is an actual improvement in that specific domain. And for that, we often end up using some of the state-of-the-art computer science methods. Sometimes, so whether it's VLMs or it's LLMs or it's standard vision transformers, etc., we are sometimes agnostic to that. We want to solve important problems and look at the state-of-the-art methods. We also, if you go to the openings page, you can see the vision and some of the reasons why you may want to join the lab, including a good GPU infrastructure, multiple years of research. Our alums are doing well at different places. And if you also want to read about their experiences, how and what they've done in the lab, so you can quickly glance through that to get a sense of what the lab culture is. You can also read about the lab culture here, what are the expectations, etc. We also have these different positions, as I also mentioned here. Some of them would be labeled with red, which are the ones which have an active deadline. The ones which are year-long, they are typically not labeled with red. But even if you don't see anything, you can always just write to me and we can take the conversation forward. And you can also go through the lab handbook to understand the complementary resources that we have, the skill sets that we have, in fact, even put up the design kit, etc. And you can read more about the publications, the people in the lab, what are they up to, the news and the media coverage, discuss about the various works being discussed in the news media. And in the events, we have events like this, which is the ACM event, and there are a couple of other events happening. So any question on this? I'll take questions offline on this. I can meet people one-to-one and then discuss this. Okay, thank you.